Hello, so I have a bonus 6x6 for you all. This is called Ballast by Toir. This is too difficult for adventure, but every once in a while I will feature a puzzle by an adventure setter as a thank you, where they made one that they really wanted showcased, but couldn't be part of the adventure series. So let's go over the rules to this puzzle. We have normal 6x6 Sudoku rules, so in every row, every column, and every 2x3 box, we're placing the digits 1 to 6 exactly once each. We also have cages in the grid. These are these cells surrounded by dotted lines. Digits can repeat in a cage in this. These are not killer cages. You can repeat digits all you want, which is good because there's more than 6 cells in this cage, for example. But the lowest number in a cage, so whatever, let's say the lowest number we place in this cage is a 2, right? That tells you how many cages that cage orthogonally touches also contain that number. So this cage touches this cage, this cage, this cage, and this cage. So that's 4 cages that it orthogonally touches. And if the lowest number in this cage is 2, that means only 2 of those 4 cages contain a 2, or exactly 2 of those cages contain a 2. The other ones do not. So a pretty unique rule there. I'll have to think about what that means. We also have thermometers in the grid. These are standard thermometers. So digits increase from the bulb. So starting from the circle, our digit increases along the line. This is just 2 thermometers overlapping, sharing a bulb. So it increases this way and it increases this way. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. I am noticing we have a bulb in this cage. So this is the smallest digit in the cage. I'm actually going to use green to mark which is the smallest digit. Now, how many cages does this cage touch? It touches almost all of them. Let's see. So 1, 2, 3, 4, 5, 6. It touches 6 cages. And it can't be larger than 4 because of the thermo. In fact, it has to be smaller than 3 digits in total. So it can't be a 4 either. If this was a 4, we'd need 5 here and 5, 6 here or something like that, or 6 here and 5, 6 here. We need 3 digits. So this is 1, 2, or 3. So only 1, 2, or 3 of all of those cages I highlighted have a 1, 2, 3 in it. Now we know that since this cage touches both of these, we know that that digit does appear in here somewhere, but only once. So this is one of the cages that has it. It also touches these 2 cages. So one of these has it as well. So that's at least 2. So it can't be, but I'm thinking about how this digit needs to go in this box somewhere. Right. So that makes it a 3 because, what's the best way to put it? One of that digit will appear somewhere in this box. So that covers one of these cages. And one of it will appear in this box, and that covers one of these 2 cages. Now, there's 2 options. One option is that it appears in this little cage here. And if it does, well, then it still has to appear in this box somewhere, which is going to include one of these cages, which this isn't. The other option is it appears up here in this cage, in which case it still has to appear here in this box, right? So I don't know if there's like a cleaner way to state that. Definitely these 2 boxes contribute one of them, one of the greens. But this box also contributes a green. Oh, but we can repeat in the cage. Ooh, if we repeat in the cage, we could have it here and here. I didn't think about that. Okay, so it could be a 2, but barely. But that does mean that these cages take care of it, right? Maybe this cage too. So this cage can't have it in it because it's touching it, and that would be too many. So I guess it's over here somewhere. I don't know. Does that help me? There's no 1 here. So 1 is here or here. I think this cage has every digit in it. So that might be helpful as well, because it's whatever the 2 digits that aren't here, they go up here. So this has a 1 in it. The 1 is the smallest digit, which means only one of these cages has a 1 in them, We know it's not this cage. So, well, actually, we know this cage has. Do we know this cage has a 1 in it? No, we don't. So either this cage has a 1 or this cage has a 1, but not both. And this can't be a 1 because of the thermo. Okay, so. Oh, so that means. Oh, so or this cage has a 1. Right. Can we get away with these cages not having 1s at all? I mean, obviously we could just put a 1 in here. So if we had a 1 here and a 1 up here, then yeah, we don't need a 1 in any of these cages. So the 1 could be in this cage. I'm not sure that goes anywhere. There might be some limitations here. Okay, so this cage only touches 2 cages. So this has to have a 1 or a 2 in it to be the lowest digit to tell us how many 1s and 2s go in here. Is there any cage that only touches 1 cage? Because that would be convenient. I don't think so. Not seeing any. This cage touches 1, 2, 3, 4 cages. So that doesn't really mean anything to me. Could still be 4, 5. Well, I mean, the lowest digit in here is going to be at least, a 3 or lower. So I feel like that. Can I really not rule out 2 from here? So this is 3, 4, 5. And this is 4, 5, 6. And this is 3, 4, 5, 6. So 3 would put a 4, 5, 6 pair here. So this 4, 5, 6 triple here. So this would be 1, 2 pair. I mean, these in general are from. What are these from? They definitely have a 1 in them. And then they have whatever this thermo's missing, which is kind of a tautology, but maybe that's the way to think about it. If this was a 3, it would be a 1, 2 pair. If this was a 2, then these could be missing any of 3 through 6, I think. So I don't think that's helpful. Is a 1 here problematic? I don't see how. We know this cage has a 1 already, so it's not problematic. Okay, so I'm missing what to do here. What cage should I focus on? Okay, so let's think a bit more about the consequence of this being 2. We know one of these has a 2 in it. And then that would force a 2. So we'd need a 2 here, and we need a 2 up here. We need a 2 up here, because the 2 would be here, right? This would be a 2. There would be 2 here. There would be a 2 up here. So 2 in this box would be in one of these 2. And these would be the 2 cages with a 2. So there wouldn't be a 2 in here. That's fine. There wouldn't be a 2 in here. That's also fine. There wouldn't be a 2 in here. That's fine. And so that does mean this cage would have a 2 in it. So only 2 of the cages touching it would have a 2 in it. That actually, that would be these 2, and that's actually fine. Yeah, that actually works out. I feel like this might be what happens. Maybe the 3 has a problem. So let's think about the 3 instead. So if this was a 3, there'd definitely be a 3 in here. So here's the problem. I don't know if this would be a 3 with a 3 up here, and then we just have like a 3 in here somewhere, a 3 right here. Or if we'd instead end up with a 3 in here and a 3 up here or something like that. Or it feels like 3 is pretty flexible. So yeah, I don't know about that. We know that one of these is green, actually. So this cage has the green in it. The green's in here somewhere. I mean, this cage needs, let's see, this touches 1, 2, 3 cages. So this needs a 1, 2, or a 3 in it. And in fact, because this has green in it, well, green doesn't have to be the smallest digit in here, though. I was going to say that we would force the 1 into here, but 1 could be the smallest digit in here. So let's say 1 was the smallest digit in here. This has a 1 in it. We know that for sure. Because it's got all the digits, right? So this would be the only cage with a 1 in it out of these. None of these could have a 1 in them if this cage had a 1 in it. I'm not sure what I'm getting at here. Seems reasonable to me. It would mean there's a 1 up here somewhere. We know this cage has a repeated digit. Let's call that purple. And it's just got the 1 repeated digit in it. It can't repeat more than 1 digit because this is all in a row. I think that's an important deduction. I'm not sure what to do with it yet. So if it was green, that's the only repeated digit in that cage. Which would mean the 1 can't repeat. I don't know if that's important. So this cage contains the green. There's definitely a green in here somewhere. It could even be purple. That's the problem. Purple and green could be the same digit, and I don't know. Did we say this can't have green in it? I think this could actually have green in it because we could have purple be green. So that would be 1 cage with green, another cage with green. And then if green was 3, it could also just be in this cage. Right here. So I can't even like roll green out of this cage. Is it this cage? How many cages does this touch? 1, 2, 3, 4. This touches 4 cages. So it just needs a 1, 2, 3, or 4 in it. I mean, it's gonna have that. It's three cells. If this was the lowest digit, it couldn't exceed 3, but there's really nothing to conclude from that. So if this was the lowest digit, it would have to be 3 because there would only be 3 cages left that could contain it. Oh wait, this cage can't contain this digit. It can contain this digit. So actually, this cannot be the lowest digit, right? Because if this was the lowest digit, this cage doesn't have it, and this cage doesn't have it. So there would only be 2 cages left to have it. And it's not allowed to be 2. So our lowest digit's over here, and it's smaller than this. That doesn't mean much to me. If this was the smallest digit, then we have this. We don't have the same issue because it could be in this cage here, right? It could even be green. Darn it. Yeah, okay. It just this cage won't have these 2 digits, which is obvious, but I'm just trying to think through this. The fact that this has a 1 in it feels really important. At least 1 in it. So only one of these cages can contain a 1. Does that restrict where 1 can go? One of these cages has a 1 in them. Problem is, I don't know which cage it is. So let's imagine the one we're in here. Then that would be the 1 cage, right? So this cage couldn't have a 1, this cage couldn't have a 1. So we'd have a 1 in one of these two. Oh, and that would break, right? Because we wouldn't be able to have a 1 over here. We wouldn't be able to have a 1 here. So the 1 would end up in one of these two, which would be in this cage, and that would break that rule. So this cage does not have a 1 in it. Which means there's a 1 in here somewhere. It's not here. Okay, so it's not this cage with the 1. So there's either a 1 in here, or there's a 1 in here. One of these two has a 1. Right, so we have the same issue, right? So if this didn't have the 1 in it, then the 1 would be in here. That points in, this wouldn't be 1. There'd be a 1 in here. Oh yeah, and so then this would be the 1 cage with a 1 in it. Okay, so that actually works. If the 1 were in here, this cage wouldn't have a 1. There'd be a 1 down here. Is this 1 broken? No, this one works. So it works either way. Darn. Works either way. At least as far as I can tell. I feel like this little thermo here is designed to remove 1 from here, but I'm not sure what that does. We know there's a 1 somewhere in this column. Also this little thermo, removing 1 from here. I don't know. We also remove 6 from here and here. This can't be 1. I think if this was a 1, it would mean green can't be 2. Because we'd have a 2 in this cage, and then the other 2 would also end up in an adjacent cage. The 2 for this row would also end up in an adjacent cage. So I think that's a clean way to see that. So if the 1 is here, then this is a 3, making this a 1-2 pair. Yeah, I'm not sure what not sure what to do about that. I felt like I got some kind of deduction that the 1 can't be in here. Okay, if the 1 can't be here, maybe we can prove the 1 can't be here. So we just have to prove it can't be here. If this was a 1, this is the only cage that could have a 1. I mean, we know this cage has a 1 in it, right? So this would be the touching cage with a 1. And so then, yeah, there couldn't be a 1 in here. So there'd be a 1 in one of these two. And then there'd be a 1 here. We're allowed to repeat. There'd be a 1 down here. So there'd be 1 in here. So one of these cages would have a 1 in them. This cage would need a 1 in it, because none of the other touching cages can have a 1. Right, so this would be a 1, this would be a 1. We'd have a 1, this would be a 1. 1, 2, 3, 4, 5, 6. Does this all work out? This cage touches this one. Nope, it doesn't work, because this cage touches both of these. So I just proved this through a very nasty way, but this can't be a 1, because if it was, then, let's see, what was our flow? Let's just go back through this. So if this is a 1, then this cage can't have a 1 in it, because of the rule for this one. Only one of the cages that touches this is 1. So only one of these two has a 1 in it. So the 1 ends up down here, which then in this box forces the 1 to be here, which in this box down here forces the 1 to be here. And then is my redoing is not working right. Darn it. Okay. So just from here, now this cage would need a 1 because this cage needs to be touching a 1 with a 1, touching a cage with a 1 in it, and this is the only one that could be. So that would be a 1, and then that would be a 1. And now the issue is this cage touches 2 cages with 1s in them. Right, we broke it as soon as we put a 1 in here. But we had to put a 1 in here, right? Just by Sudoku, it ended up here. Okay, so yeah, that doesn't work. So this is not a 1. This is not a 1 because of the thermo. We can't put a 1 in this cage. We proved that already. So this ends up being the 1. And so the only repeated digit we have, purple, is the repeated digit, which is a 1. Which means we can't repeat the green, which means the green has to be a 3. Because if the green was a 2, the only way that worked is if we repeat the 2 here and here. So this is a 3. We can clean that up a bit. This is a 1-2 pair. All right, what do we do from here? So this cage has a 1 or this cage has a 1. If this cage has the 1, it's here. This cage has the 1, it's here. So 1 is somewhere in here, right? I guess that's not super interesting. That's just what the row says. So I'm just going to corner mark 3s here. And okay, so 3 of the cages this touches have a 3 in it. So this is one of them. This is another one for sure. So we only get one more cage with a 3 in it. And this row is going to need a 3. So one of these cages, the other 3 is going to be here. So we don't get another 3. We don't get a 3 here. We don't get a 3 here. So 3 is somewhere in here, I guess. We can't put a 3 in here is the point. What's next? This cage here, it's only touching this cage, and this cage. We know for a fact that this cage doesn't have the same digit as this cage here, right? I'm going to make this purple just for a second. So the purple cage is touching this cage, and this cage. Obviously, we can't have purple in here. Now, the lowest digit in this cage, first of all, it can't be the 3, right? So could the lowest digit in this cage be this 4, 5, or 5, 6? No, because there's only 2 cages that can have the digit that repeats. And it's not going to be this one. So this has to have a 1 in it. It has to have a 1 in it, which means there's a 1 over here. And that means it's touching a single cage with a 1 in it. It's not this one, it's not this one, right? We just proved that. So the 1 ends up here, and that places the 1 here. This was just purple for demonstration purposes. And so that works out. And so now this cage can only touch one cage with a 1 in it. So this can't be the 1. This is 2, this is 1. Okay, progress. Now this cage needs to touch 2 cages with a 2 in it. So that makes this a 1-2 pair, like this. And then the 2 in this cage has to go here. Now this cage has to touch 2 cages with a 2 in it, and it does. It means there's no 2 in here, though. Touches these 2. So this can't have a 2 in it. So the 2 in this box is up here. Actually, it's placed. Very nice. Okay. That puts a 2 exactly here. So now this touches 2 cages with a 2 in it. This is one of them. This is not one of them, right? So it has to be this cage. This cage has a 2 in it somewhere. And it's one of these 2 cells. Yeah. By Sudoku, actually exactly here. Sorry. By Sudoku, this is a 2. But it works out for the cage. This is not green. In fact, we don't need green anymore. This cage touches 2 cages with a 2 in it. Yes, it does. Okay, it's these. All right, that's working out. This is at least a 4. This is 4, 5. This is 5, 6, just for this little thermo here. All right, is there anything I can do with 2s? 1, 2, 3, 4. Our 2s are done. How about our 1s? They're reduced to here. They're reduced to here. Yeah, so the 1s are just resolved this way. Now, the 2 is the lowest digit in this box. Oh, did I know that the 2 had to be the lowest digit in this box? It touches 2 boxes with a 1, so I think that's true. I think this can't have a 1 in it. So I hope I didn't make a leap of logic there, but I'm just going to keep going. So we have the 1 there and the 1 there. Ones are done. The 3 goes here, these pointing 3s. Puts the 3 there. I really hope I didn't do a logical leap there. This is 4, 5, 6. No, I think I placed this tube not because it had to be the lowest in here. It had to be, did it have to be the lowest in here? Yeah, this couldn't have a 1 in it. Yeah, I think that's all accurate. I don't think I made a leap of logic. I may not have fully thought it through, but I think it was fine. So what's next? These digits are the same. Okay, we need a 4, 5, 6 here, but this digit goes here, so this can't be a 6. So this can't be 1 or 2, so this is 3, 4, 5. It's not a 3 either, so this can't be a 4. That's a 4, 5 pair, so this is a 6. This is a 3. We get a DD2 in the corner. This is 4 or 5, making this 5 or 6. 5, 6 pair. So that means there has to be a 5 up here, right? So this is 4, this is 5, this is 5. That's a 4. We get the 6 here, we get the 4 here. This is our 3. That places the 3 here. Okay. I think we're wrapping up. This is a 6. This is a 4. This is 5 or 6. This is 5 or 6. It can't be the 6. That's 5, that's 6, that's 5. 4, 5, 6, 5, 4, and 6. And we got the correct solution. Okay, good. Neat puzzle, Toir. Really cool idea. That was quite intricate to think about. It was obvious that this cell was important, but I couldn't prove it wasn't 2 for a while. I had to do a chain on this not being 1. There were only 2 places in this row that could have been 1, and I had to prove it couldn't be this one by seeing where it would place all the 1s and seeing it broke this cage. So I don't know if there was a cleaner way forward. Probably there was, maybe not. But I did make it through, so hope you enjoyed the solve. If you did, then why not leave a like, subscribe, and a kind comment below.